What if gravity isn't weak? It sounds ridiculous at first. Gravity sculpts galaxies, crushes stars into black holes, and can shake the universe hard enough to send ripples of space-time across billions of light years. Yet a toddler can defeat it with a helium balloon, and a small magnet can lift a paperclip as if Earth's pull were nothing. So by what standard are we calling gravity the weakest force in nature? Here's a stranger possibility. Maybe gravity isn't weak at all. Maybe it only looks weak because we're measuring it from inside a cramped, three-dimensional room of reality. Imagine living on a thin sheet of paper and trying to understand a three-dimensional world. You wouldn't see the full shape of anything, only the shadows that slice through your plane. In the same way, what we experience as gravity could be the faint projection of something bigger. A force that spreads into hidden dimensions we can't access, while the other forces remain trapped in the dimensions we inhabit. This isn't just science fiction. It's a serious idea that connects Newton's falling apple, Einstein's curved spacetime, and modern theories that require extra dimensions, ending with a radical picture of the universe as a brain floating in a larger bulk. Stay with me, and we'll follow the clues that make weak gravity look less like a fact and more like a perspective error. For a moment, hold on to that unease. The idea that gravity might not be weak at all, that we might simply be looking at it from the wrong kind of space, does not go away just because we are used to feeling heavy and safe on the surface of a planet. Out in the dark, gravity is anything but shy. Take a massive star at the end of its life, many times heavier than our Sunday. As its nuclear fuel runs out, nothing is left to hold up the weight of its own material. Gravity wins. The core collapses inward. Temperatures and densities surge to extremes that language barely reaches. In some cases, this implosion triggers a supernova or even a hypernova, an explosion that for a short time outshines billions of ordinary stars in a galaxy. Now, place next to that the most powerful nuclear device humans have ever built, the Tsar Bomba, tested by the Soviet Union in the early 1960s. Its blast yield was measured in tens of millions of tons of chemical explosive. For us, that number sits at the edge of imagination. Yet, compared to a stellar detonation, it is almost nothing. A spark in the corner of a vast, burning sky. On cosmic scales, gravity is the executioner.